All right, hi everyone. This is a reprise of a talk I've given uh, as a lunch and learn at work, and just recently gave at the Triangle ReactJS Meetup. And I tried to record my screen as I was giving it at the meetup, but things didn't go quite right. So this is just a reprisal of that. Going to run through uh, reactive programming in JavaScript slash intro to RxJS, kind of what powers it, what are some common use cases, and what are some things to keep in mind, more or less. So just a relatively brief overview, and then I'm going to show some examples via CodePen. So I'm Peter Elbaum. I'm a software engineer at Smashing Boxes in Durham. We do design and web, mobile IoT development, and I'm PJ Elbaum on Twitter. So if you want to find me, that would be cool. Diving right in, what is reactive programming? So reactive programming, from the Angular docs, it is an asynchronous programming paradigm concerned with data streams, propagation of change. Data streams is the important part there, so it deals with change over time. So that will come into play later. We'll get into some examples. RxJS is this library that we're talking about, included by default with Angular, and it enables reactive programming through callback base code by using observables. So observable is the default async type in when you're using RxJS. So by default with Angular, you're getting observables when you're using the HTTP module, things like that. But Rx and observables are platform agnostic, so you can use it in React apps. You can use RxJS in React. There's a Vue module, I believe, and there's an Rx Python and Rx Ruby. There's an Rx Java, which they use at Netflix, so they're platform agnostic. So observable, as I said, it's kind of the thing powering the Rx libraries in general. So what are they? It is, as I said, the default async type with Angular, with RxJS. They may eventually be native in the browser, so there's currently a proposal that's going through the process with TC39, which is Technical Committee 39 of ECMA, aka the JavaScript overlords. This is the standards committee. They determine what features make it into the language. And so there is a proposal out for observable, which is in stage one. So it's passed all of kind of the preliminary checks, but it's pretty early on. So TBD on whether or not that'll make it in this round, but I wouldn't be surprised if there's native support in the browser at some point for the observable type. It's used for event streams, so think of it as a collection of events. So an array being just a list of values. Think of an observable as being a list of data that arrives over time. So every time something happens, this event or whatever it is gets added to the end of the array. So it's a lot more dynamic, kind of like promises, but with more features. It's maybe not a great way of explaining it, but I think for most people, a promise is kind of the closest mental analog that they have. It is an async type as well, but it's predicated on a few different ideas. Like I said, we'll get into that with some examples. But if you're new to this, just think of it kind of like beefed up promises for the time being. So this is kind of a visual picture of what's happening. So this model says different events, for example, string values. I don't love string values. I think probably a better use case is button clicks. So yeah, I don't know. I think thinking of like DOM interaction is more helpful here. So instead of like 1, 2, ABC, just think like mouse click, button click, key up, stuff like that. But the point is, these values are arriving over time, and then eventually they stop. The event stream is complete. Maybe there's an error, maybe not. But the point is, you're subscribed, as we'll talk about, to whatever this stream is, and as the data arrives, you get it, and it can change over time. So very powerful. So this is an example of how you would create a promise. So observable from event, so that creates an observable. So from button click, debounce 500 milliseconds, so it'll wait that long, and then console log you clicked. So you see the dot subscribe there. That's kind of like a dot then on a typical promise. Just as a quick review, I want to make sure I'm not leaving anyone behind. So quick review, what is a promise? So asynchrony is a thing. I'd say one of the most defining parts of doing front-end web work is dealing with asynchrony, aka when you make a request from your browser to an API, you don't know how long it's going to take for the return value to come. So the promise represents the completion of that process, the completion of an asynchronous operation and its resulting value, right? So if I make a call to some API, let's say I'm, on Spotify or YouTube getting a list of videos or something, I don't know when that's going to resolve. And so the promise is just kind of like a stand-in, the IOU of front-end development, I like to call it. So it's saying there will be a value here eventually, but it hasn't resolved yet. And when you're composing them, you can use resolve reject. And then when you're working with them for your callbacks, .then, .catch, as I said, an observable that it's .subscribe, and then there's a little bit of a particular way syntactically for handling errors, but that is the basic idea. Also wanted to touch on operators and subjects really quickly. Operators are functions that build on the observable foundation, also called the bread and butter of reactive programming. They allow for sophisticated manipulation of collections, which is just a fancy way of saying functional programming. So if you're familiar with regular JavaScript, plain vanilla JavaScript, you have map, reduce, all of these wonderful functional methods that are built into the language. And there are a ton of these, which I'll show, even just a list in the documentation of operators. So that's what they're called. They give you all of this wonderful kind of functional programming power, and you're able to chain them together. And so at that point, things begin to get really powerful. So like a typical use case with that would be, I mentioned RxJava at Netflix. They use it on their backends for piping server logs and kind of filtering. And so that's when this kind of stuff gets really, really useful and powerful. Also wanted to touch on subjects. Subjects are a kind of observable that allow for multicasting. So typically it's a 1-to-1 unicast ratio. So one subscriber, one observable, and each new subscription would result in a different value. But with subjects, the same observable is able to cast the same value to multiple subscribers. So we'll get to that. Really quickly, I mentioned a few different times that this is part of Angular by default. And so I want to touch on why that's the case. First of all, Angular has a lot of features. So this is my attempt at humor. Me, some random tech, will they include this in Angular? I actually had a coworker the other day that was fooled by a gag article saying that there would be support in Angular core for Bitcoin mining. And that's funny, but to a certain extent, you can kind of see how he would fall for something like that. Angular has a lot of features. It will be smaller in 2019. So they say, but like I said, it's a fully featured framework, and it's just got a lot more going on. So to a certain extent, I think that is a decision made at the maintainer level, and I can't be 100% certain, but I had a colleague make a very good point that observables and RxJS, having those self-contained data structures fit really nicely with the Angular service layer. So for those who aren't familiar, Angular has a little bit more of an opinionated structure than something like React that's just a view layer. So when you use the Angular CLI, you get the application structure out of the box, and you can generate your services, which are the pieces of your application that do the calling to the APIs. And so it's kind of built-in state management, which is really great, coming from someone that isn't super fired up on Redux. And yeah, so I can't say for certain, but I think that's probably a big part of why they decided to include it. So examples, I'm going to get out of this real quick. And okay, so first thing. So this is a compare and contrast more or less of observables and promises. So I have an observable here, I have a promise. So single versus multiple values. Promises can only emit one value, and promises emit one value, observables emit multiple values. So if I do a refresh here, you can see I get 5. So number promise dot then, console log me the value, please. But the thing is that, the thing is that promises can only resolve one value at a time. So it resolves once and it's done, and that's it. And so when I try and resolve a 10 after the 5, you can see I only get the 5. But if I clear out here and then uncomment number observable, you can see I get 5 at first, and then the observable resolved first. So 5 and 10, and then 5. So observables can emit multiple values. Just to drive that home, I'm going to clear this out and refresh. I'm going to save, actually. CodePen's a little picky, right? So if we do a refresh with just the observable, 5 and 10, right? So that's one feature. Eager versus lazy, that's another feature. So if I go ahead and refresh, so I have this promise, just constructing it, and then I have an observable that I haven't subscribed to yet. And so the promise gets called right away, even though nothing is subscribed to it. So I have some notes down here. The reason for that is that the initialized promise represents something that's already happening, like a request, and we're just waiting for the resulting value. That's because the function, so the constructor, right, that is called when it's created, is starting the process right off the bat. So as soon as I call new promise here, there's nothing I can do. It go ahead and fires off this console log. But the cool thing about observables is that it can define what should happen without the thing actually having happened yet. So as I say down here, it represents a process that might start happening. So it's cool to be able to define what should happen even without having it happen right then. So if I clear that out and subscribe, you can see I was called from promise, I was called from observable, so I can go ahead and define a new observable without anything happening. Cancelable versus non-cancelable. So basically, the crux of this is that a promise is, we said back here, as soon as it's constructed, it executes, and you can't stop it. As soon as the process is started, it will complete. But the cool thing about observables is you can stop subscribing from that data stream whenever you want. And so I've got an observable here. Every second it's emitting value +1, and I'm subscribed to it. So as long as I'm subscribed and unsubscribed, nothing is going to happen. But if I'm just subscribed, like normal, We can see it's starting to tick away here, 1, 2, 3, 4, etc. And that will continue to happen until I unsubscribe. So you can see here we're at 10, 11, and we're done, 13. So you can hook into that data stream and subscribe to it. You can also say that you don't want that to be the case anymore and unsubscribe, which is also super cool, very powerful feature. Subjects I mentioned, being able to cast the same value to multiple subscribers. So this is the case, new subject, subscribed here, and then going to emit a random value. So if we get a refresh in here, you can see the same number cast two different places. So that can be useful under certain circumstances, certain use cases, but just important to know that that is a possibility. And then lastly, operators. I actually wanted to show the whole list of operators here, just because there's a lot going on. They moved the documentation. I'm not sure where it is. Operators. RxJS docs. Yes, so they have it on this Firebase app for some reason. But if we go to the reference and then functions, these are the operators. So look at all of these. Just tons and tons of functionality. Honestly, I don't encounter most of these on my day-to-day. Most of what I need to get done doesn't require it, but it's just important to know what's there, I think. So there's debounce, buffer time, error catching, concatenating stuff, flat map, multicast, scan, which is kind of like a reduce, which I'll show you, just all kinds of stuff. So one quick example, just requiring in a few of those, and then as I said, you can make an observable out of a lot of different stuff. This is just a list of values, so it's turning that into an observable. And so for each thing, we're using this pipe method, which is built in. So what's going to happen is, and the pipe is how you chain the operators together. So you get that nice kind of functional power. You can chain one operator after the other. So we're going to filter for even numbers, map over them and double them, and then basically do a reduce and add it to the one that comes before. And then, of course, subscribe at the end. So we'll see what the result is here in the console. So that's what that turns out to be, 4, 12, 24, 40, and 60. So kind of interesting. Nothing, particularly relevant about that necessarily, but it's just an example of showing what can be done. So that is a basic overview, intro to RxJS. I would be remiss if I didn't give a shout out to, there's a particular article on Medium that I got a lot of these examples from. So let me see if I can find this guy. It's basically promise verse observable and Medium with this guy this is him, Matauj. So these are where I got the examples from, so I just wanted to give Matauj a huge shout out. Thanks for all your great writing, and I hope you guys found this helpful, and I'll see you in the next one. Thanks.